Hello everyone, welcome to the channel Yashpal's Physics Notes. Today we are going to study the topic moment of inertia of solid cylinder. As you can see in this figure, I have drawn one solid cylinder with purple color. Now in step number 1, what we are going to do, we are going to label this diagram. So in this figure, let x dash be the geometric axis. So here I am writing from above figure x dash is the geometric axis of this cylinder. Geometric axis of the cylinder. Let capital L be the length or height of the cylinder. Length, or we can say height of the cylinder. Height of the cylinder. Now here in this figure, as you can see, I have drawn one circular disc with red color ink in this solid cylinder. Here we are assuming that this solid cylinder is made up of such small number of circular discs which are stacked on each other. So if we stack such circular discs on one another, we can finally get complete solid cylinder. Here we are going to find the moment of inertia of this solid cylinder around the y dash axis. Here y dash axis is nothing but the axis passing through the center and perpendicular to geometric axis of the solid cylinder. So here I am writing y dash is nothing but the axis passing through the center of cylinder and here you can see it is perpendicular to the geometric axis of the cylinder. So here I am writing axis passing through the center of cylinder and it is perpendicular to its geometric axis. So geometric axis is nothing but the axis which is passing through the center of the solid cylinder. Now we are considering let I be the moment of inertia of cylinder about this y dash axis. So let I, capital I, be the moment of inertia of the cylinder about the axis y dash. So ultimately what we are going to do, we are going to find this moment of inertia of solid cylinder about y dash axis. Now here you can see, as I have drawn a circular disc with red coloring, we can consider the solid cylinder is made up of such n number of circular discs stacked on one another. Next, we can say let capital AB is the diameter of this circular disc. So here I am writing capital AB is the diameter of the circular disc. Also we can say let capital R be the radius of this circular disc. So I am writing capital R be the radius of circular disc. And let dx be the thickness of this circular disc. So here I am writing, let dx be the thickness of circular disc. So here we have done the labeling the figure. As you can see from the figure, xx dash is nothing but the geometric axis of the cylinder. Capital L, we have considered length or height of the cylinder. If the axis y dash, which is passing through the center and is perpendicular to geometric axis, is dividing this cylinder into equal parts. So here, as you can see, I have shown with L by 2 and this side with L by 2. So total length is capital L. Y dash, as I told you, is nothing but the axis passing through center of cylinder and it is perpendicular to its geometric axis. Next, we have considered capital I as the moment of inertia of cylinder about the axis y dash, which we are going to derive in next steps. We have considered AB is the diameter of circular disc. We have considered that this solid cylinder is made up of such n number of circular discs. Then we have considered capital R is the radius of this circular disc, which I have shown with red color, and dx is the thickness of this circular disc. Now in step number 2, here I am writing step 2. In step number 2, we are going to find the volume of circular disc of the cylinder. With circular disc, here I have shown circular disc with red color. We are going to find the volume of the circular disc of the cylinder. So here I am writing in step number 2, volume of circular disc of the cylinder. Let volume is be the capital V and its formula is given by area into thickness. Area into thickness. As I have told you, this solid cylinder is made up of n number of this circular disc. So here we are considering the area of circle. As you can know, the area of circle is pi r square, where r is the radius of this circular disc, which I have considered capital R. Area is pi r square and we have considered thickness as dx. So this is the volume of circular disc of cylinder. So give this equation number 1. Now in step number 3. In step number 3, we are going to find the mass of elementary portion of cylinder, which means we are going to find the mass of this circular disc which we have considered, which having the diameter AB. So here I am writing in step number 3, we are going to find the mass of elementary portion of cylinder. Elementary portion of cylinder, which is nothing but the small circular disc which we have considered. So its formula is given by, here I am considering mass of this small elementary portion as small m, which is given by volume into mass per unit volume of cylinder. So here from step number 1 we have already found the volume. So here I can write from 1 we get, what we are going to do is we are going to substitute this volume in above equation. Therefore small m is equals to pi r square dx. Now here mass per unit volume of cylinder. Now I am considering capital M is the mass, total mass of this solid cylinder. So here I am writing capital M is the total mass of this cylinder per unit volume of cylinder upon, now we know the formula of volume of cylinder is nothing but the pi r square L, where L is nothing but the length or height of this cylinder. Now here we can do some cancellation. Pi r square gets cancelled out. Now I am writing the remaining term. Therefore, small m is equals to capital M upon capital L into dx. So give this equation number 2. Don't get confused here. Small m is the mass of this red circular disc which we have considered, and capital N is the total mass of this solid cylinder. Now in step number 4, here I am writing step 4. In step number 4, we are going to find the moment of inertia of this small circular disc which we have considered. Okay, so here I am writing moment of inertia of any disc about the diameter, which means we are going to find the moment of inertia of this circular disc, and then if we integrate that, we can get the moment of inertia of the complete solid sphere or solid cylinder. So here I am writing moment of inertia along AB, where AB is nothing but the diameter of this circular disc. So here I have written moment of inertia of any disc about diameter is given by IAB is equals to, its formula is 1 by 4 into mass into radius square. So here I can write 1 by 4 and mass we are considering for circular disc which was small m. So here I am writing small m, and radius of this circular disc is capital R. Here we have written in step number 1. So it's capital R square. Now here we are going to substitute the values of small m, that is mass of this circular disc, which was ml dx, and this r square as it is. After rearranging, we get the term moment of inertia about the diameter for circular disc is equals to 1 by 4 m r square upon L and this dx. So give this equation number 3. Now in step number 5. So what we are going to do in step number 5, we are going to find the moment of inertia of the disc of cylinder about the axis y dash. How we are going to find? We are going to use the parallel axis theorem. As you can see, if we consider this axis AB which is passing through this circular disc and y dash as another axis which is parallel to this axis. So here we are going to apply the parallel axis theorem in our step number 5. So here I am writing, let di be the moment of inertia of the circular disc which we have considered, circular disc of cylinder about axis y dash. Remember in step number 4 we have find the moment of inertia of this disc about the diameter. which was considered AB as the diameter. Now here we are going to find the moment of inertia of the circular disc about axis y dash. How we are going to find? We are going to use the parallel axis theorem. So here I am writing by using parallel axis theorem we get. So in the figure we are going to use the parallel axis theorem. First I am going to write here di, which is the moment of inertia of circular disc about y dash axis. Formula is I AB plus m x square. So from figure you can see we have considered this circular disc, which is considered with which I have shown with red coloring, is at distance small x from this y dash axis, and it is a perpendicular distance. So as I have written di, di is nothing but the moment of inertia of circular disc about this y dash axis, which will be equals to moment of inertia of circular disc about its diameter, that is I AB, plus m is the mass of this circular disc and x is the perpendicular distance which is separating these two axes, that is AB axis and y dash axis, which are separated by distance x. So according to the parallel axis theorem I have written this formula. Now here I can substitute the values of IAB which we have found in step number 4. So here I am writing substituting values of IAB and small m, which we have find in equation number equation 2, and here we have given equation number 3. Substituting values of IAB and m in above equation. So therefore our equation becomes di is equals to 1 by 4 m r square by L dx plus what was the value of small m? It was ml dx into x square. Now here you can see there is the term m by L and m by L in both terms. Okay, so we are going to take out common. So our equation becomes therefore di is equals to ml, taking common. Now write the remaining terms, r square by 4 and here x square, and also at the same time dx is also common. So here I am taking dx as also common term and writing it outside. Here I am again writing as a note capital M is the mass of solid cylinder and small m is the mass of circular disc. L is the length or height of the cylinder. Length or height of cylinder. Dx is the thickness of circular disc. Thickness of circular disc. Now in step number 6, here I am writing in step number 6 what we are going to do, we are going to integrate this equation number 4. Give this as equation number 4. If we integrate this equation number 4, we are going to find the moment of inertia of whole solid cylinder. So here I am writing step number 6. So in step number 6 we can write moment of inertia I of cylinder, moment of inertia capital I of cylinder about the axis y dash can be obtained by integrating equation number 4 with taking limits x is equals to minus L by 2 to x is equals to plus L by 2. Now see, in this figure of solid cylinder, this axis y dash is dividing the solid cylinder in two equal portions. Okay, so if I consider here example, if we take a coordinate axis, okay, this is our coordinate axis, here we take 0. Now you know that on the right hand side of this there are positive values, okay, positive terms, and in the left term of this 0 there are negative values. So same we are going to consider here also. We know that length cannot be a negative quantity, so we are going to do some adjustment there. But for taking the limits, we are going to take the limits from plus L by 2, from minus L by 2 to plus L by 2. So we are considering the portion which is on the left side of this axis y dash as limit minus L by 2, and the portion which is on the RHS as plus L by 2. So that's why I have written here moment of inertia I of cylinder about axis y dash can be obtained by integrating with taking limits x is equals to minus L by 2 to x is equals to plus L by 2. Remember that length cannot be a negative quantity, so we are going to do some adjustment there. So let's integrate. So here I am writing therefore I, that is nothing but the integration of dx, and we are considering limits from minus L by 2 plus L by 2, and I am writing this equation ml by L r square by 4 plus x square into dx. Now see, we cannot take length as a negative quantity. We know that length cannot be a negative quantity. So what I am going to do, I am going to remove this lower limit, that is minus L by 2, and I am going to replace it with 0. How can I do that? See, if I consider from this figure, if we consider this O as our coordinate axis, okay, we can consider the values on the right side of this coordinate axis as positive axis. What if I consider this portion, only this portion on the RHS side, that is portion on the RHS of y dash axis? If we consider only this half part, and if I multiply it by 2, see here the length, total length is L. If I consider only this half part, that is L by 2, here I am writing L by 2, and if I multiply it by 2, what I get? Ultimately I am going to get the total length L of the cylinder. So that's how I am going to remove this lower limit minus L by 2. So here what I am going to do, I am considering only this right side of the y dash axis, and I am going to multiply it by 2 to remove the lower limit minus L by 2. So here I am writing therefore I is equals to, see here, 2 limit 0 to L by 2. what I have done, let me correct, L by 2. So what I did here is I have removed this negative term minus L by 2 and I have replaced it by 0 and multiplied this whole equation by 2. So ultimately we get the final answer as we desired. So here I am writing the remaining term as it is ml r square by 4 plus x square and dx. Now we know that capital M is the total mass of the solid cylinder which is not changing. Also capital L is the length of the solid cylinder which is also not changing. So I can take it outside of this integration. So here I am writing twice M L integration limit 0 to L by 2 capital R square by 4 plus x square into dx 2m by L. Now here I am going to separate these two terms and integrate them separately. So here square bracket 0 to L by 2 r square by 4 into dx plus integration 0 L by 2 x square into dx. Here I have separated the terms and integrate them separately. Twice m upon L. Now here you can see that capital R, which was the radius of the circular disc, which was not changing. For example, if I had taken a circular disc here, so see the radius of this circular disc and radius of this circular disc will remain same, which is not changing. So radius here is not changing, so I can take it outside. So here I can write, wait a minute, so here I can write r square by 4 and 4 is the constant term, so I can take both outside of the integration. So I can write remaining term 0 L by 2 dx plus 0 L by 2 x square dx. Now here we are going to do integration. Twice m upon L r square by 4. Now integration of dx is x, putting the limits L by 2 0. Also integration of x square is x cubed by 3 and putting the limits L by 2 0. Curly bracket. Here also I can write the curly bracket. Okay. Now here we are going to substitute the values. Is equals to twice m upon capital L. Here r square upon 4. So here I can write L by 2 minus 0 plus. Now here I can take this 1 by 3 and I'm going to write x cube with limits L by 2 to 0. Curly bracket close. Now in next step I can write here twice m L and here curly bracket r square upon 4 into L by 2 plus 1 by 3. Now here I can write L by 2 whole cube minus 0. This curly bracket closed. which will be equals to twice m upon L. Here I can multiply these terms, r square L upon 8 plus 1 by 3. It will become, after cubing this term, L cube upon 2 cube is 8 minus 0. We can neglect this term. Twice m upon L r square L upon 8 plus L cube upon 24. Bracket close. Now see, there is a term L on both the terms. Okay, in both terms there is a L term. So I can take one L term outside. So here I can write twice m L upon this L, and what I am remaining with, r square 8 plus L square 24, L square upon 24. So here I can cancel out this term, this with this, write the remaining terms. So twice m. Now see, in the term there is a multiple of 8. So if I taken out L outside this bracket, so I can take out 8 outside this bracket, but we are remaining inside bracket, r square plus L square by 3. What I have done is I have taken 8 common outside this bracket because it is a multiple. So here I can cancel out this term again 4 times and this 1 time. So write the remaining term. So this is nothing but the moment of inertia I. So therefore moment of inertia I is nothing but m by 4 r square plus L square by 3. Now if I multiply this term inside by 4, so ultimately we can also write this equation in this form. I is equals to m r square upon 4 plus L square upon 12. Give this as equation number, what was our last equation, 4, and this, give this equation number 5, and this as equation number 6. In exam you can write till equation number 5, or further you can expand it till equation number 6. Both are correct. So here we have derived the moment of inertia of solid cylinder about the axis y dash. So here is the figure. Once again, y dash is the axis passing through the cylinder, and it is perpendicular to the geometric axis of this cylinder. So we have find out the moment of inertia for the solid cylinder about the axis y dash. So this was your final answer. Thank you for watching.